Welcome back, and I've got a fun experiment for you today. What I thought we'd look at is the way physicists measure the different volumes of the sounds that we hear. The scale that physicists use to measure the level of sound that we hear is called the Decibel Scale. This was named after Alexander Graham Bell, who produced a working model of the telephone many years ago. It's quite interesting to note that, in fact, he married a woman who was deaf, and his mother was deaf as well, so he was really interested in sound and how the ear responds to it. So physicists needed a way of comparing different sound levels. And so what they did is create a sliding scale called the Decibel Scale. You'll notice it's not measured in bells because the bell is too large a unit. So the decibel, the tenth of the bell, is used. And it's also interesting that it's spelled only with one L, even though it's named after Alexander Graham Bell, whose name had two L's in it. So to do this experiment, we need two things. Firstly, we need a way of measuring the sound pressure level. And I've got a decibel meter here, which has a scale on it that tells us how loud the sound is. And the second thing, of course, we need is a source of sound. And what we're going to use today is a small baby. The decibel scale runs from values of 0 decibels, which is the quietest sound you could ever expect a human ear to hear, right up to values beyond 100 decibels. And once you're getting into the region of about 120 decibels, it really begins to hurt. It's the threshold of pain. And anything above 140 decibels, and you are going to do damage to your hearing, if not make yourself permanently deaf. But unfortunately, it's a little bit more complicated than that. The human ear is an incredible device, and it has the ability to hear an absolutely massive range of sound intensities. The numbers would start very, very small and go up to absolutely massive numbers. So the decibel scale is a logarithmic scale. And what I mean by that is, if we have 0 decibels and we 10 times the sound intensity, we get 10 decibels. If we 10 times it again, we don't go up to 100 decibels, but we go up to 20 decibels. And 10 times it again, that's 1,000 times more intense, 30 decibels, etc. So it's a logarithmic scale to the base 10. And to cope with the huge range of intensities of sound, the human ear has developed some quite clever ways of working. And one of them is that if you go up by 10 decibels, the sound only gets twice as loud. So if you go from 50 to 60 decibels, you've gone up 10, and our ear only hears that as a doubling in volume. Now, just before I completely baffle you, there's one other thing I'd like to let you know. I'm going to use a sound pressure meter, and I'm going to switch it to the dBA scale, the A weighting. I need to do this because the human ear doesn't hear different frequencies linearly in terms of volume. In fact, what has to happen is lower frequencies and very high frequencies actually have to be more intense for us to hear them at the same volume. And the dBA scale takes that into account. So we've got everything we need to do the experiment. We've got a small baby who's going to make some noise, and we've got a sound pressure level meter. Now, one thing I would like to say is I didn't control the variables very well here, and that's something you can look out for. I moved the sound pressure level meter closer to him, further away. Sometimes I took it out completely just to get the shot. But it's a bit of fun, and we can certainly go some way to explaining the different sound pressure levels that a baby produces. So, any of you that are new parents will know that these little fellas make an awful lot of noise. At the moment, he's being lovely and quiet, and I can just about hear him breathing. So that's not 0 decibels, but it's about 20 decibels, a really low level on the scale. But what we're going to do is record him over a period of time and see all the different sounds he makes and compare those to the decibel scale. So, if you remember that the decibel scale is an increasing scale of loudness, let's start off with Barry sleeping. Now, my meter wouldn't even read sound pressure levels this low, but I think what we're looking at here is about 20 decibels. So here he is now awake, and I would say that the sound level he's producing is about 40 decibels. So we laid him down and got him to play with some of his toys, and we're now at about 45 decibels. So to the human ear, that isn't quite twice as loud. It would have to be 50 decibels than when he was just awake and not doing much. So he makes all kinds of funny sounds when he's feeding, but drinking from the bottle here and with the sound pressure level meter quite close up, we found we were getting about 50 decibels, which can be described as a faint sound. Now we're going to get a little bit louder, and this was a really funny one. He seemed always after feeding to develop hiccups. So we were at about 20 decibels, and then suddenly the sound pressure levels spiked up to about 60 dBA. Now, something I didn't know about young babies, because I've not had any before, is the fun cooing sort of sounds they make. It's almost like they're trying to talk to you. And close up, this is like a conversation, and it's about 80 dBA. Now, that's as far as all us new parents wish the decibel scale went up with babies. But of course, it goes much, much higher. And we're going to go above 80 now. And remember that if we get up to 90 decibels, that's just counting up by 10. But it's an increase in intensity of 10 times the intensity. And as you know, babies do like to cry. Now, I don't want to distress the little fella, but sometimes babies cry for no reason at all. And he's quite capable of producing sound pressure levels of 120 plus dBA. These are the kind of levels that if you're in an industrial situation, you'd have to permanently wear hearing protection, or you would do damage to your ears. So it's a good time just to mention one more thing. We haven't got twins, but what would happen if you had two twins bawling their eyes out and screaming? Would it sound twice as loud? And the clever thing about the human ear is it wouldn't. If you remember the decibel scale, to go from 100 to 110 is a 10 times intensity, which our ear hears as twice as loud. So you'd have to have 10 newborn babies all bawling their eyes out to make a sound that our ears hear as twice as loud. The decibel scale is not an easy thing to understand, but I hope with Barry's help you understand a little bit more about it now, and perhaps have learnt a little bit more about why logarithmic scales are important to physicists. So I hope you enjoyed that video, and thanks to Barry for helping me make it. More videos soon, and I look forward to seeing you then.